Okay, recording. Um, I will, as I mentioned, to make up for last Monday when we didn't meet, and maybe for this coming Monday when we're not going to be able to meet, I will cut down the lectures so they're a little bit more palatable for you to kind of view online, and I'll get them up into the course environment and let you know about it, and have a couple of little assignment activities to focus your viewing of the online lectures. But for today, I really just want to give you kind of an overview for thinking about how our thoughts of Mars have changed and our place in the universe overall over this period from about 1550 to today. Okay, so realistically, we've had this huge shift in our thoughts about our place in the universe, our overall worldview. It's been an amazing journey that humans have gone on intellectually and conceptually. Going back from the previous view of this distinct separation between what is going on up in the heavens versus what's going on Earth, with the heavens being this unknowable realm that have these points of light in the sky that are moving around, as opposed to this imperfect view of what we have going on the Earth, to the point now where we're thinking of Mars in particular, the subject of this course, as this new world that we can explore remotely at this point, but ideally within hopefully my lifetime and certainly your lifetime, this would be a place, a world that we could actually physically explore in person. So there were 3 or 4 major components to that shifting worldview. I just want to lay out for you to help you think about the materials that are covered in those assigned readings that we've had so far for the term. Okay, this one we actually talked about a week ago, although we didn't quite finish it up, and I'll put more of this online. But obviously the first and most fundamental change here was the Copernican revolution. This was critical for breaking down this barrier, this distinction between what is going on Earth versus what is going on the heavens. The Earth just becomes part of a much larger universe, and that in turn makes all of these planets that were kind of unknowable lights in the sky, turns them into other worlds that we can apply our experience on Earth to understand. As we talked about, both of these concepts did an adequate job of explaining various observations, like how the planets and stars and the sun and the moon moved in the night sky and the daytime sky. But in terms of evaluating predictions like the phases of Venus, which I'll put more online about, over time it was really accepted that this heliocentric view of the universe is a better representation of what's going on, even though our day-to-day observations and our senses make us think that the Earth might be this unmoving center of the universe. Really, the conceptual advances, the examining the predictions, allows us to kind of break out of being controlled by what we just see in our day-to-day observations to come up with this larger idea of the Earth being just one of many worlds that goes around the sun, which in turn is just part of this larger Milky Way galaxy. Now, clearly you all grow up in our modern culture with an understanding of a heliocentric view of the solar system and the universe. So it's second nature to you. But if you kind of really put yourself in the mindset of someone 600 years ago who was growing up in that geocentric model, hopefully you can get an idea of just what a fundamental shift this was. And I'll get off my soapbox, but just think about that. So, well, let me just. Who were some of the major names, the major players involved in the Copernican revolution? I won't bother going back on the slide, but who would we have been talking about? Tycho Brahe played a role in terms of having the observations that triggered a lot of the investigations. Kepler. And definitely put a lot more information about Kepler and his laws of planetary motion. So Kepler was important. Herschel, not so much. Herschel we'll talk about on this slide. Okay, but in terms of the Copernican revolution, well, nobody said Copernicus. So obviously Copernicus, Kepler. What role did Galileo play? Phases of Venus. Again, providing some of the new kinds of observations that tipped the balance toward the heliocentric view. So that was maybe 1550 to the early 1600s, late in the Middle Ages, clearly before the Renaissance and the Enlightenment and so forth. It was really this shift that sort of led the groundwork for the later period of Enlightenment and Renaissance and all of the changes in society and culture and so forth that occurred in Europe afterwards. With the geocentric model, part and parcel of that was the idea that not only was the Earth fixed in place, but so really were kind of societies and individuals. And if I were born back in the 1400s, I would have been a poor peasant like my forebears. And this idea of progression and all of that stuff that came later really was triggered to some extent by the revolution in worldview that the Copernican revolution brought about. So the next phase is kind of understanding, well, if Mars is a world like the Earth is a world, what can we say about it? And so this is, again, the early period of telescopic observations. You have crude drawings of light and dark structures on the surface of Mars as seen by the observers. These patterns of light and dark markings are basically differences in albedo, the lightness or darkness of the different part of the planet. And that's basically what observers had for the period from the early 1600s through about the middle 1700s, late 1700s. What were the important aspects of Mars as a planet that were actually discovered during this time?
The poles.
Okay, so we have polar caps. Where else are we familiar with polar caps?
Here.
On the Earth. Okay, so we're seeing something on Mars that reminds us of something we're familiar with here on the Earth. What are some of the other important observations during this time?
The Hourglass Sea.
Okay, the Syrtis Major, the Hourglass Sea here. By tracking the position of features like the Hourglass Sea, early observers were able to tell what about Mars?
Its rotation.
It's spinning, okay, and and the spinning of Mars obviously is the same, similar to the spinning of the Earth. It causes our day and night cycles. And what was discovered very early about Mars in terms of its day length?
Same as ours.
About the same as ours, okay, so about 24-hour day. give or take, give a little bit longer than 24 hours. We've got polar caps. We can tell by looking at these features on Mars that Mars is tilted on its axis, similar to what the Earth is tilted on its axis, which would lead to what happening on Mars? Seasons. Okay. So there's this period in the mid 1600s and early 1700s where people are doing their best to observe what they can see on Mars, and Mars is looking very, very much like the Earth. Similar day length, there are polar caps. Those polar caps change, they grow during what would be the colder seasons, they shrink during what would be the warmer seasons. So we're talking about winters and summers on the northern and southern hemisphere of Mars. We're talking about a day length that's very similar. Get this idea, a very important idea is put forward during this time period of plurality of worlds. That, we know Earth as a world that is full of life and humans and intelligent life. If all of these things that used to be points of light in the sky are now worlds, many of them may also be very hospitable worlds. Of this plurality of worlds idea is there may be hundreds and thousands of worlds throughout the universe that are Earth-like and can support life the way we do. So people were talking about inhabitants of the moon, inhabitants of Mars, inhabitants of Jupiter, which we now know is kind of silly. But it was this idea that before the Copernican revolution, we had humans on Earth, and we had this realm of perfection up in the heavens, and now all of a sudden we have this explosion of potential worlds that may have their own peoples on them. That's got to be quite a kick in the head to the view of people. So let's see. Somebody mentioned Herschel. Yeah. So Herschel was talking about this seasonality, and because he was really the one who really focused on that axial tilt and the seasons. And talking about the Martians, the inhabitants of Mars, experiencing a situation very much similar to our own. So, clearly Herschel is an important name here. What other names?
Say the polar caps were made of ice, right?
There's a lot of discussion about what those polar caps could be.
No, but he was the first guy to say that.
Herschel was not the first person to discover the polar caps,
No.
but he was the one who really made the argument most thoroughly about that they would be ice. Okay? So again, this is another example of that use of analogy. We know something about the Earth. We have polar caps on the Earth. They're made of ice. They melt away during the summer, they get larger in the winter. We see similar kinds of behavior on Mars, so we can make an analogy that, well, maybe we can say that there are polar caps of ice on Mars. And indeed there are, but they're not quite the same as the polar caps on the Earth. So Herschel, Huygens, Cassini, these would be many of the names that would be involved in this stage. So then things kind of settle down. We've kind of made all the fundamental changes. We've broken down the barrier between Earth and heavens. We think of Mars as another world. If Mars is another world, then, well, what have we done with our world? We've mapped it. We've spent a lot of time mapping where the continents are, where the cities are, where people live, and so forth. So that period of understanding what Mars is like as a world was followed by this period of, well, let's get a handle on what is going on Mars by doing what we can do, which is to map it. So you get this period primarily in the 1800s. maybe late 1700s through the late 1800s, where every time Mars comes around in its closest period, location on to Earth during opposition, telescopes are trained on Mars to look at those patterns of light and darkness and to try to map out, the physical features and any kind of artificial features that might be seen on Mars. This is more kind of just refining our view of Mars. There's not any fundamental change in conception of the world that's involved here. It's more a matter of getting more and more accurate observations and collecting those observations into maps that tie all of them together. Now, what allowed people in the 1800s to map Mars in this detail compared to the crude sketches that were taking place in the 1600s and 1700s? People were smarter in the 1800s?
Was it that the telescope, the Huygens and Cassini?
Okay, so telescope and the development of telescopes is really what drove the advances in Mars exploration during this time period. And that is, that's a fairly fundamental thing you should realize about science. Oftentimes, the technology that we have will determine what kinds of observations we can make and what kinds of explorations we can make. I mean, before we had the telescope, Mars was never anything more than just a bright point of light in the sky. As telescopes developed and got better and better, we got better and better views of Mars, and so people could think about mapping Mars in the 1800s based on the advances in telescopes that they had compared to, this would have been impossible in the 1500s or even the 1600s, because telescopes were not good enough to show any kind of detail on the surface of Mars. We are still doing that today. Much of the reason why we understand Mars better today is that we can develop and send to Mars even better instruments that allow us to measure things that we can't even detect from our senses. So, microscopic imagers, spectrometers that are measuring different wavelengths of light, visible, invisible, X-ray detectors, things that allow us to ask questions about the world in ways that we can't just relying on our unaided senses. Any names that you want to throw out for this period of time? The main areographers, the people who mapped Mars during the 1800s. Beer and Madler. Madler being the money in the operation, and Beer being the actual observer. Schiaparelli is probably the most important name in this time period. There are others: Dawes, Proctor, Asaph Hall, who worked in the Naval Observatory, also did some mapping of Mars, but was responsible for discovering the moons of Mars. But Schiaparelli in particular was one of the most influential mappers, and worked toward the latter half of the 1800s into the early 1900s, and developed some of the most detailed maps of Mars. There were other investigators who focused more on, Schiaparelli was colorblind, and so he was very much focused on making very refined measurements of where light and dark structures were seen on Mars. And so the accuracy of his mappings were probably greater than anyone who was working else who was working at the time. But because he's colorblind, he couldn't, look at some of the other features like, very subtle gradations in color. So the maps really kind of vary in some of these properties that you see developing during this time. Schiaparelli was also very critical in describing these structures on his maps of Mars that he called canali in Italian, which means channels. But what does canali sound like in English? Canals. And it's this work that Percival Lowell really drew on to drive his exploration of Mars. He's born in a wealthy family in Boston. Let me skip through some of this. His key contributions were in a couple of areas. He set up his own observatory out in Flagstaff, Arizona, as opposed to putting up an observatory in Boston. Why would you go out to Flagstaff if you're have a better view? Okay, the desert air, less cloud, less humidity in the air. You have a greater chance of having less turbulent air at night when you're trying to observe. And so observations during the telescopic period of exploration, not only limited by the quality of the instruments that people had, but also the quality of the seeing, the conditions that people had to look through. Connecticut, not the best place to set up an observatory, even if you've got a very high, nice telescope, because the atmospheric conditions just are not as good. Today, most of the ground-based telescopes, the really important ones, are at very high altitudes. They're up on the mountains in Chile or in Hawaii or other locations where you get desert air, and the higher you get, the higher the altitude that you have for your telescope, the less of the Earth's atmosphere you have to look through, and so you get much better quality of observations. That's why there are many important research telescopes down in Chile, up in the mountains, in the Andes Mountains, and then a lot of telescopes in high altitudes in Hawaii. Okay, so part of his contribution was the idea of setting up a facility where really high quality observations could be made. He also was very important in popularizing the exploration of Mars. He was sort of the Carl Sagan or Neil deGrasse Tyson of his time. He did a lot of public lectures. He did a lot of popular writing in weekly magazines and so forth, and put all of his arguments together in three major texts: Mars and its Canals, and Mars as the Abode of Life. These all came out in the early 1900s. And Mars as the Abode of Life is what I want us to focus on today. I just wanted to put up the foreword to Mars as the Abode of Life, because this really lays out what Lowell was attempting to do in this text. This is essentially a text-length argument that he's making from first principles to the end, and that's what we want to look at today. But he's talking about astronomy in the past had been focused on kind of predicting positions of stars and planets and understanding what were the mechanisms that led to Mars moving across the sky and so forth. But over time, astronomers became more interested in these planets as worlds. So he talks about, that the gravitational astronomy is talking about how planets move in relationship to, the gravity of the sun and things like that. What Lowell is trying to do in his arguments is to essentially develop a new field of science that he calls planetology, which is essentially how do you understand the origin and development of planets, the stages they go through, what their eventual fate is. So he is attempting, before Lowell there was all of this work on astronomy, and also before Lowell there was all of this work by Darwin and others that were describing the patterns and processes that controlled the evolution of life. And so what Lowell is trying to do is join those two large areas together by describing how planets develop out of the astronomical conditions that they arise in, how they develop over time, and how the development of planets in turn influences the development of life. Okay. So what I want to turn to now is for you to get into your groups, and I want each group is focused on a different chapter. There are 6 chapters that make up the argument that Lowell is setting out most fully in his last book here. And for each of the chapters, we need to figure out what are the key arguments that Lowell is making in chapter 1, for example. What prior work and new observations is he using to make those arguments? What assumptions is he drawing on to make those arguments? And how is he putting those observations and our prior understanding assumptions, how is he putting that all together to develop, to actually structure the argument that he's making? What's the logic behind the arguments he's making? What are the fallacies that might be leading to weaknesses in it? So let's take about 20 minutes for you to discuss in your groups and come up with a description for each of the chapters. What are the key arguments that he's making in that chapter? And then we can analyze how that all fits together into this larger argument that he's trying to make.